A small body, initially at the origin, moves in a straight line with acceleration 6t minus 10 meters per second squared, where t is the time in seconds. When t is equal to 5, it was observed to have a velocity of 31 meters per second. We want an expression for the velocity, and that's going to be the integral of the acceleration. So that's going to be 3t squared minus 10t plus some constant. We have this information here to help us work out the constant. So v is 31, t is 5, so 3 times 25 is 75, 10 times 5 is 50, so 31 equals 25 plus c, and that tells us that c is equal to 6, and therefore v is 3t squared minus 10t plus 6. Determine the acceleration of the body when v is 19. So, v is 19 gives us 3t squared minus 10t plus 6 equals 19. So 3t squared minus 10t minus 13 is equal to 0. Now presumably, since this is non-calc, we can factorise this. So we've got 3t and t. If we put the 13 here and the 1 here, and make this one a minus and this one a plus, that would do the trick. So t is going to be 13 over 3, or t is going to be negative 1, and of course that one's not possible, as we can see just here. So the acceleration is going to be 6 times 13 over 3, take away 10, these cancel, so a is going to be 26, take away 10, and so a is going to be 16 meters per second squared. Determine the velocity of the body as it passes through the origin for the last time. Well, we know that it starts at the origin. So to get the displacement, we're going to integrate the velocity . So that's going to give me t cubed minus 5t squared plus 6t plus a constant. And then we know that x is 0 when t equals 0. So in other words, x is going to be t cubed minus 5t squared plus 6t. Well, we can factorise that, so that's going to be t squared minus 5t plus 6. So x is going to be t, and then that looks like it's going to be t minus 2 and t minus 3. So it passes the origin when t equals 0, t equals 2 and t equals 3. So t equals 3 is the last time that it goes through the origin. So the velocity then will be 3 times 3 squared minus 10 times 3 plus 6. So that's going to be 27, take away 30, add 6, giving us 3 meters per second.